Hi everyone, welcome back to my channel. In today's video, we will cover the basic of Go data type. So in a Go or Golang, one of the first thing you need to understand is that is a statically typed language. Now what does that mean? Basically, when you create a variable in a Go, you have to know what type of a data it is going to store. Is it number, a word, or true or false value? That type is lock-in when the code is written, not when the program is running. So let me give you simple example. Think of it like filling out a college form. When you write your name, there is a specific box for it. Same with your age, it goes into the number box. You can't suddenly start writing your address in the age section, right? That's how Go works with the types. It wants to keep everything neat and strict. Now Go has a different type of a group into the three main categories. First, we primitive types. These are the most basic ones, like integer for whole numbers, float for decimal numbers, boolean for true or false, or string for tags like names, city names, and anything in a quotation mark. Then we have a composite types. These are the use when you want to store the group of values, like array stores the fixed number of items, like a marks in a 5 subject. Slice is like an array but more flexible. You can add more items as you go. A map store key value pairs. Think of the student roll number map to their name. And struct is like a custom data type. You can bundle the multiple values together like a student name, age, and score in a one group. And finally, these are the special types. So these are the a little more advanced, but still good to know. Interface helps when you want to different types to follow the common rule, like all vehicles having the start function, whether it is a car or bike, function types. Because yes, in a Go, even function can be treated like values. Channel is used when a program does multiple things at once. It helps them talk to each other, and pointer is a way to directly access the memory. This sounds scary, but it is very useful for performance. Now let's talk about the integer types in a Go. Now in a simple words, integers are just a whole number like 5, minus 10, 1000, and any number without a decimal point. In a Go, there are the two main categories of integer type, signed and unsigned. Let me break that down. Signed integers can both hold the positive and negative numbers. So things like a minus 20, 0, or 100. In a Go, you will see this written as an integer, integer 8, integer 16, integer 32, and integer 64. The number here like 8 or 16, that's the number of the bits the number used in the memory. So integer 8 use the 8 bits, integer 16 use the 16 bits, and so on. That also decide how big or small your number can be. Then you have a unsigned integers. These are the only for the positive numbers like 0, 50, 1000. No negatives allowed. These are the written as u integer 8, u integer 16. So here's something interesting. When you just write a integer or u integer without the number, Go picks the size based on your system. So if your computer is 64-bit, it will probably use the 64-bit. That make it faster, but it also a bit unpredictable if you are not careful. So why you should care? Let's say you are building a small app like student mark calculator. You might use u integer 8. If the marks can be negative, you know the number will always be under the 255. That's a memory efficient and clean. But if you are working with the data coming from outside, like reading a file from a file or network, it is safer to use a fixed size type like integer 32 and u integer 16. So your data behaves the same on all the machines. So yeah, understanding this type of early on your help you write a better and cleaner and more predictable code. So let's talk about the floating point type example in a Golang. So here we have defined the two variables, float32 with a pi and float64 with a gravity. Now let's take an example of real world code. So here we have a Go program demonstrate to use of a two different floating types, float32 and float64. Pi is a declared as a float32, which is a 32-bit floating point number with a limited precision, and gravity is a declared as a float64, which is a 64-bit floating point number offering the higher precision value. So the fmt statement output the values of a pi and gravity to the console. This is useful for illustrating the Go handle the two different floating types. Now let's see what is the output of this console. So here you can see value of a pi is a 3.14 and value of a gravity is 9.8665. Alright, let's talk about the complex number in a Golang. So now if you have studied a basic math in the school, especially during the 11th or 12th, you might remember the complex number. You know the number that you have a real part and imaginary part like a 3 plus 4i. In Golang, we actually have a built-in support for complex number. That's pretty neat, right? There are the two types you can use. First, there is a complex 64. This means both the real and imaginary parts are stored using the float 32. Basically, it's a bit lighter and take up the less memory. And then complex 128, which use the float 64 both parts. This one give you more precision. So you just like a choose between the float 32 and float 64 based on how accurate you want to your decimal to be here too, and you choose the complex type depending on how the precise your values you need to be. Now suppose you are doing the some signal processing work, or maybe you are working with the scientific formulas in places where the complex number actually comes up. Go gives you a built-in tool to handle them easily. If you ever need to pull out just a real part or just an imaginary part from the complex number, Go gives you a two function, real and image. Super handy. So goes not just about the simple web server or APIs, it's a powerful enough to handle the mathematical stuff too. So here we have taken one example of complex number in a Golang. So here we have a defined one variable with a complex 64 equals to 1 plus 2i. Now let's try to understand by this code. So here we have a Go program defines the complex number z with the real part of 1 and imaginary part of a 2 using the complex 64 type. The real z function extract the real part 1 and image z extract the imaginary part 2 of the complex number, and real of z and imaginary part z then prints the both value to the console. So let's see what should be the output of this console. So here you can see that 1 and 2 as expected. Let's start with something super simple but essential in the programming, the Boolean type. So you will see this lot, and understanding is the key to working with the condition and making decision in your code. So in a Go, the Boolean type is called bool keyword. Now bool can only have a two possible values, true or false. That's it. Just like when you are taking a decision, you can either say yes or no, true or false. For example, let's say you are writing a program that checks whether the student has passed or failed based on their marks. If their marks are above an certain threshold, you can set the result to true or false. So here's the cool part. In a Go, the default value of a boolean is false. So if you declare the bool variable but do not explicitly assign it the value, Go will automatically set it to false. Why does this matter? Well, think about when you are using the if statements, like when you are checking the condition in your code, bool values help make those decisions. So if you something is true, the code inside your if statement runs, and if it is false, it will not. So here we have taken one example of a boolean type. Let's see in the code. So here we have a declare the variable with a where is go fun boolean equals to true. This line declares the boolean value of true, and the conditional statement, if the statement check if the value is go fun is true, Since the variable was initialized with the true, the condition will be satisfied and the code inside the curly braces will be executed. So the final output should be a Go is awesome. Alright, let's talk about the strings in a Go, something you will use a lot whether you are building a small tool or big backend service. So in a Go, string is basically a bunch of text like a name, message, or even a paragraph. But here's something special in a Go. String is a UTF-8 encoded sequence of byte. Now that sounds a bit technical, right? But do not worry. All it means is it supports the pretty much of any language or symbol you throw it. English, Hindi, emojis, everything, and store it efficiently in a memory. Also, strings in a Go are immutable. That means once you create a string, you can't change it directly. So if you try to update a letter or modify the part of it, so Go will not allow that. You have to create a new string instead. Another cool thing, you can create a string using the double quotes like a hello or backticks like a hello slash n world. The double quotes work like a normal. You can add escape characters like slash n for new line. And here's a small catch. Go treat strings as a bunch of bytes, not character. So if you are working with something like a Hindi text or emojis, where one character might take a more than one byte, you will need to be careful while accessing or slicing the strings. To work with the strings, Go gives you a tills like a slicing or len, which tells you the number of the bytes, not characters. This is really useful when you are trying to process the data, building the APIs, or just to debug the output. So here we have taken one example of a string type in a Golang. Now let's see in the code itself. So here we have a one variable which is called the greeting string and assign it the value hello go. The FMT package is imported to allow the formatted input output such as a printing to console. So here line outputs the value of a greeting variable to the terminal. So final output is Go is awesome. Alright, let's talk about the arrays in a Go. So in simple words, an array is a fixed size of collection of elements. That means once you decide how many items that you want to store, that number cannot change later. It's like a saying that I want exactly 5 slots to store the number. That's it. So you are stuck with a 5. Now in a Go, the way we define an array using this format of nt. So here the n is a length, like how many elements you want, and the t is the type of each element. So for example, if you want to store the 3 integers, you will write something like a 3 and integer simple. One important thing to note that this is something a beginner often miss. Arrays in a Go are values type. So what does that mean? Let's say you have an array and you assign it another variable. Go will copy the entire array. So if you change the second one, the first one stays the same. They do not share the same memory. This is very different from the some other languages where array are reference types. Now here's something practical. Even through array exist, they are rarely used directly in a Go. Why? Because Go has a something more powerful and flexible which is called the slice. We can talk about in upcoming slides. So now as a beginner, don't stress too much about the memorizing all the details of array. Just understand the basic fixed size, type, and copy on assignment. You will be good to go. Now let's take in an example of array type in a Golang. So here you can see we have a numbers of 3 integer which is have a 3 fixed size length, and we have simply printing our numbers. So now let's see in a code. So this code defines the array name, numbers with a fixed size of 3 elements. All of the type is integer, and it is initialized with the array with the values of 1 to 3. Now FFT println numbers output the entire array to the console and displaying 1, 2, 3 in a bracket. So alright, now let's talk about the slice type in a Go. So basically slice in a Go is like a more flexible version of an array. You can think of it like this. Imagine an array is a classroom with a fixed number of chairs. If you want to add more students later, you can't unless you shift to the bigger room. But slice is like having a folding chairs. You can bring in more chairs whenever needed. That's why we say slices are dynamic and flexible. Now in terms of a syntax, if you want to declare a slice of integer, you had write integer in bracket. That's just a square brackets without the size followed by the data type. So a bracket of a string would be slice of a string and so on. Now what make slices really useful are few built-in function that's come with that. One is append. Append helps you to add more items to the slice. Super handy when you do not know in advance how many items you will need. And copy. Copy lets you duplicate the data from one slice to into another. And slicing is just a way to take the portion of a slice, like saying that give me the first three elements and everything after the second element. Internally, a slice is just a random. It actually holds a pointer to the actual array in a memory along with the two numbers, length, which is how many items it currently has, and capacity, which is the total space available before it needs to grow. So if you are writing the real world Go code, like building a web app or doing some backend work, you will definitely use the slice a lot. So this is the slice type example in a Golang. So let's see in a code. So here this line declares and initialize the slice of integer. In a Go slice, slices are more flexible than the arrays and can grow or shrink. And here you can see that integer 10, 23, 20, 10, 20, 30 creates a slice with the three elements like a 10, 20 and 30. And here we have appended one more number with the 40. So it will append to 42 existing numbers. And since slices are backed by arrays, if the capacity is not enough, Go will allocate a new unrailing array with the more spaces. So the final output should be 10, 20, 30 and 40. So here you can see that 10, 20, 30 and 40. Alright, let's get started with the maps in a Go. So in a Go, a map is a collection of a key value pairs. Think of it like a dictionary where each word key has a meaning value. So if you are familiar with the dictionary, this concept is a pretty similar. What exactly does that mean? So map in a Go allows you to store the data in a pairs, key and value. The key is like the unique identifier for the data and the value is the actual data associated with that key. For example, let's say you have a list of a student in a class and you want to store their marks. You could use the student name as the key and their marks as the value. Some important things to remember about the maps in a Go. Key must be a comparable type. This means you can use the types like a strings, integer or boolean as a key, but not slices, maps or function. That's because Go need to compare the keys to know where to store and find them. How to check if the key exists in the map? So if you want to know the whether it is a particularly key exists in your map, you can use the simple pattern like value OK equals to map of key. So here val is the value you get for that key and OK will be the boolean that tells you whether the key exists in the map or not. If the key doesn't exist, OK will be false. So in a simple words, maps let you store the data in a structured way using the key and values, and you can easily check if the key is exist or not. So maps are super useful in real life application like managing the user data, storing the configuration starting where you need to fast look up by the specific key. Let's see the example of a map type in a Golang. Now we can see in the code itself. So here we can see that this code creates a map called scores, which stores the names of type string as a key and that their corresponding values scores as a values. So in this case, map is initialized with the two entries. Alice has a score of 90 and the Bob has a score of 85. The fmt score Alice line prints the score of Alice to the console, which in this case will be output 90. So map is unordered collection of a key value pairs. You can access the value using the key like scores of Alice. If the key exists in the map, it returns the corresponding value. Alright, let's dive into the structs in a go. So I will keep it simple for you. Imagine that you are trying to model something in the real world like a student. A student has a many characteristic like their name, age, roll number and courses they are taking. Now instead of keeping all these things details scattered around as an individual variable, it's much cleaner to bundle them into the single and custom type. That's exactly what a struct does in Go. So think of it struct a way to group related pieces of information together under one umbrella. In a Go, we call this as a custom data type. For example, you can create a student struct where the student name, age, roll number, and subject are grouped together. This helps the keep the data organized and easy to manage. But wait, structs does not hold the data. They can do lot more. You can add the methods to the struct, meaning you can have a function that works specifically on that struct data. This makes struct very powerful when you are building more complex system. Another cool thing about the struct is the way they support the nesting and embedding. So you can have one struct inside another, which is really useful when you need to build a more complex object. Now let's try to understand the Go struct example. So let's switch into the VS Code. So in this Go code, we define the person struct type, which has a custom data structure that hold the information about the person. In it has a two fields: name, which store the person name, age, which stores person age. We can create a variable p of type person and initialize it with value John or for the name and the 30 for age. So finally we print the name of a field p struct to the console using like a p dot name and p dot age. So what should be the output of this console? Let's see. So here you can see that person name along with the age, which is a 30. Let's talk about the pointers in a Go. So now if you have heard about the pointers in a language like a C or C++, you probably know that they can be tricky to handle, but in a Go, pointers are bit safer, which is good thing for us beginners. So what are the pointers? So pointers are variable that store the memory addresses instead of actual data. Think of it like having an address to a house. Instead of sending the letter directly to the house, you just send it the address. The recipient address can take the letter and do something with it. How do you use the pointers in a Go? So syntax of for pointers, if you want to declare the pointer to certain type, you use the star t, where the t is the type of a data you are pointing to. For example, if you have a pointer to integer, it is written as a star integer. Getting an address, to get the memory address of the variable, you use the AND operator. So if you have a variable x and you want to edit address, you will do address of x. Dereferencing. So once you have a pointer, you can access the value at the memory address using the star. For example, if a p is a pointer, so star p gives you the value stored at the address of a p points to. Why this important? Because pointers can help you the memory manage efficiently. For example, if you have a large data structure like an array or slice, you want to pass it around a function using the pointer. Avoid the copying the entire data. This can make your program faster and more memory efficient. So let's take an example of a pointer type in a Golang. So let's switch into the VS Code. So this code demonstrates the usage of a pointers in a Go. Here we have declared the x and initialize with the value 10. The pointer p is assigned to address of x using the AND operator. The AND operator gives the memory address where x is stored, and we are actually dereferencing the pointer. The star p in the FMT println expression dereference the pointer to the pointer p. This means that it accesses the value stored at the memory address p points to, which is the 10 in this case. So the output is 10 as expected. So this demonstrated how pointers works in a Go. So let's talk about something really interesting in a Go function type. In Golang, function are actually treated like a first class citizen. Now I know that sounds a bit fancy, but don't worry, it's actually very simple. Just like you can store the numbers in a variable, you can also store the function in a variable. That means function can be treated like any normal value. You can pass function as an argument to another function or even return the function from another function. This gives you a lot of flexibility when you're writing a code. Another cool thing is Go also support the anonymous function. These are the function without the name. Think of it like writing a small piece of a logic on the spot and without creating a full separate function for it. Why is this important? Let's say you are writing a program that does some operation on the list of number, like filtering even numbers. Instead of writing a big and name function, you can just pass a small anonymous function that does the job. Super handy, right? So here we have taken one example of a function type example in a Golang. Let's switch into the VS Code. So here we have a use the we will create the custom type name operation which represent the any function that takes the two integer values and return as an integer. Then afterwards we will use the passing function as an argument compute. So compute function accept to another function which has a parameter. You can pass the behavior into the compute without hard coding logic. Then afterwards we will use the anonymous function assigned to the variable which is called add. So you can store the function in the variable and pass them around them. And then afterwards you can use the using this function to the variable which is you are passing to add function into the compute to perform the addition. This shows the how flexible function are in a Go. And another function we will use for the multiplication. So here we have a use switch logic dynamically just by passing the different function to the values. So functions are the first class citizen in a Go. Now let's see what should be the output of this multiplication and as well as the addition. So here you can see that addition 15 and multiplication 12. Alright, let's talk about the interfaces in a Go. Now if you are new to the programming, don't worry, I will keep it this super simple. So first, what is an interface? Think of it like this in your real life. If you are hiring someone for a job, you care about what they can do, right? Like, can they write the code? Can they design? Can they test? You do not really care which college they went to. You just want to know if they have the skills. Interfaces in a Go work the same way. So interfaces in a Go specify the method sets. This means that interface simplify defines what method or type you must have. It's like a saying, I do not care what you are, as long as you have this function. For example, let's say you have an interface called speaker and it requires one method speak. Now any type that has a speak method automatically satisfies the speaker interface. And that brings us to the next point. A type satisfies in the interface implicitly. This is really cool in a Go. You do not need to say that, hey, my struct implement this interface. No, need for extra keywords like implements. If your type has the right method, Go just know it's automatic, super clean, right? So this is like a empty interface doesn't require any method at all. So any type, a number, string, struct, whatever can fit inside it. So here we have taken one example of interface type in a Golang. So the speaker interface defines the contract that any type you must fulfill if I want to be treated as a speaker. It requires the speak method that returns the string. Docstruct has a method speak that returns the whoop, which satisfies the interface. In the main function, so let's see in the code itself. So here we have defined the type speaker with the interface and dog as a struct. Then afterwards we have implemented the speak method for the dog. So here we will use the struct and speak method we can use. Now in the main function, a variable of a type speaker is assigned to dog value. Since the dog implement the speaker calling the s.speak, that is whoop. So let's see what should be the output. So here you can see that whoop is printed. Alright, let's talk about the channel type in a Golang. Now if you are just getting started with the Go, you have probably heard this term channels being thrown around. But what exactly is a channel? So think of it like this. Imagine you and your friend are working on a coding project together. You are writing one function, your friend is writing another, but at some point your function need to send some data to your friend's function so they can use it. That's where channels comes in. In a when two Go routines which are like lightweight threads needs to talk to each other or pass some data, they do it using the channel. There are the three main types of a channels in a Go. Chain T, this is the bidirectional, you can send and receive the data through it. Chain less than T, this is the send only, you can only send the data into this channel. And less than chain T, this one receive only, you can only get the data from this channel. Now don't worry, we will look at the actual code example in an upcoming slide. For now, just understand that this type of help you can control how the data flows between the different parts of your Go program. And one more thing, channels in the Go can be either buffered or unbuffered. An unbuffered channel is like a handling over a file in a person. Both the sender and the receiver needs to be there at the same time. In a buffered channel is more like a dropping that file into a tray. The receiver can pick it up later when they are ready. So why does this matter in real world coding? Well, if you are building something like a messaging app or backend service that can handle the multiple tasks at once, channels help you the manage how those tasks talk to each other without getting it in each other's way. They are super useful for writing the clean, efficient and concurrent code. So this is the example of a channel type in a Golang. Now let's see in the code itself. So here we have a create a bidirectional channel of a type integer. In a Go, chain T means the channel can both send and receive the values of type T. In this case, it is a sending and receiving the integer. Then afterwards, send data function. It takes in a parameter of a type chain less than integer. This means that the channel is send only. We can send the data into it, but we cannot receive from it. So in the function, we send the value 42 into the channel. Now in the next line, you can see receive data function we have a call. So it takes the parameter of a type less than chain integer. This means that the channel is receive only. We can receive the data from it, but we cannot send any data into it. So here we receive the data from the channel. So in the main function, we create the channel, launch a Go routine to send the data into the channel using the send data ch, and then we can call the receive the data ch to get the value from the channel and print it. So now let's see what should be the output. So here you can see that 42 value as expected. Now let's talk about the rune and byte types in a Golang. So rune is basically an alias for integer 32. It is used to represent a single Unicode character. For example, a character from the different language like Hindi or Chinese are represented as a runes. In a Go, you can think of it as a way to handle those special characters. Byte is just an alias for U integer 8. So it is typically used to represent a binary data and most commonly ASCII character. If you are working with a raw data or need to deal with a lower level things like a file handling, you will work with the bytes. Now you might wonder why this matter. Imagine you are building an app that handles the text in a multiple language. Using rune will help you work with the those complex character. On other hand, if you are handling the text that's a plain in English or working with the files, byte will come in handy. In real world scenario, when you are doing string manipulation or dealing with the data at the byte level, knowing the difference between the rune and byte is a key to handling your data properly. So this is the classic example of rune and byte in a Golang. Now let's see in the code. So rune is a data type in a Go which represent a Unicode code. Point character is a typically used for the large characters like Indian rupee symbol. In the code, R is assigned the value rupee and byte is an alias for the U integer type in a Go representing the 8-bit value typically used for the storing the ASCII character. The variable B holds the value A, which is the ASCII code for the capital letter A. So now let's see what should be the output of this console log. So here you can see the rupee Unicode is 8377 for the rupee symbol and 65 is the ASCII value for the letter A.